Hi, hello, good afternoon. Hi, hello, good afternoon. This is Maruti Prasad Satluri. This is Maruti Prasad Satluri. I have more than 13 years of experience in teaching chemistry for EAMCET, JEE and NEET students. Okay, yeah, please subscribe this channel. Don't forget it and like it as well as share it. This is Unacademy YouTube channel. This is Unacademy YouTube channel. Don't forget to share it, subscribe it and like it. And before I'm starting this session, I want to say something about the plus subscription. There are so many number of benefits by taking this plus subscription. We will deliver the premium content which is at affordable price, and structured live courses will be there with dedicated live doubt clearing sessions and so many number of quizzes at regular intervals for getting self analysis, and so many number of batches will be conducted for complete preparation of the syllabus, and test series for daily practice papers and full length mock tests with complete analysis. Okay. And by taking single subscription you will get unlimited access. You can utilize 20 plus top educators and plus batches, 250 plus courses and 2000 plus lessons, and many more will be added every day. This is my code. Maruti Live is my code. Once you are applying my code you will get 10% of instant discount, but everything is under single plus subscription. Okay. And one more important thing is Unacademy is giving two best plans for EAMCET 2021 aspirants. One is 12 months plan and the second one is 6 months plan. 12 months plan is 12,375, whereas 6 months plan is 10,125. It is 1000 approximately and it is 1600 rupees approximately. But multiple batches are launching every month. Don't forget to use my code, that is Maruti Live. Maruti Live is my code. Once you are using my code, you will get 10% of instant discount out of the total amounts. And one more important thing is, just now I have mentioned in the earlier slide, that is so many number of batches like comprehensive batches. These two are, one is for physics, chemistry and biology, and the second one is for physics, chemistry and mathematics. Okay, it is a 6 months full batch and it is 8 months full batch. If you have not enrolled, please enroll now immediately, don't forget it. And it is a Telugu batch for AP and TS EAMCET 2021. You can learn from the best educators, and detailed explanation in Telugu language is for better understanding, and complete syllabus coverage will also be there, and wherever necessary we will give the tips as well as tricks to you for time save as well as for better score in the examination. And for this Telugu batch the monthly trial plan is 2250 rupees. Maruti Live is my code, but if you are using my code you will get 10% of instant discount out of the total amount 2250. This batch has already been started on 12th of October. Please enroll now immediately, don't forget it. Yeah, that's all. So we'll continue the session from the previous, that is chemical properties. We have already seen the chemical properties in the last class, right? Just మళ్ళీ ఒకసారి గుర్తు తెచ్చుకుందాం. Again we will recollect it. That is oxidation process. It is very important for us. Oxidation process. Okay. Yeah. Just a minute. Yes. Oxidation process. In the oxidation there are three different types of methods we have. One is, yeah, sorry, actually the chemical properties I have not discussed, right? We need to discuss the chemical properties. I think the complete chemical properties we need to discuss right now. Yeah, let us see one by one. Sorry, let us see one by one. Yes, see here. Chemical properties. out of which the first one is halogenation. The first one is halogenation. Halogenation. What is the meaning of halogenation? Halogenation means adding of the halogen, addition of halogen to alkanes. If you take any of the alkane, it should be added with one halogen. So what are halogens actually? Fluorine, chlorine, bromine, and iodine and astatine. Of course, astatine is a radioactive element we should not use here. And in the same way, if you take the fluorine reacts with halogens very vigorously, very rapidly and very violently also. Vigorously or violently. So violently the fluorine can react with the alkanes. It is very rapid process. That's why we are treating the alkanes with chlorine or bromine or iodine. But one more important drawback is there with iodine is once the alkane reacts with iodine, it will form a product, no doubt, no problem. But the formed products are again combined together and forms the reactants again. So we have to stop the products itself. So how can we stop it? Later we will see. Okay, halogenation first we will see. I am taking the methane as an example and chlorine is other halogen example. Once you are treating the methane with chlorine in the presence of sunlight, if you are treating with chlorine, methane treating with chlorine, then it will produce CH3Cl plus HCl will be produced. Okay, and this methyl chloride, it is called methyl chloride actually. Methyl chloride again is combined with chlorine in the presence of sunlight again, because there are so many number of hydrogens. There are 3 hydrogens. So these methyl chlorides one again reacts with chlorine and it will produce CH2Cl2 plus HCl. This CH2Cl2 when it again reacts with chlorine in the presence of H nu or sunlight, it will produce CHCl3. It is called chloroform. It is called as chloroform. This chloroform is again finally treated with chlorine or finally reacts with chlorine and produce CCl4 plus HCl. So these 4 type of chemical reactions can be done in the halogenation process of a methane. So what is the main important point in this case here is, here we are taking only 1 mole of methane but 4 moles of chlorine. So we are taking excess amount of chlorine here. But once you are taking excess amount of methane, it will only produce the methyl chloride and it will stop at this moment. It will not convert the carbon tetrachloride. It will stop at the methyl chloride. It will stop at methyl chloride. So it will not converts to carbon tetrachloride. Carbon tetrachloride ga convert avadu. Okay. So this is all about halogenation. But one more important thing is, suppose if you take fluorine and chlorine and bromine and iodine. So the chemical reactivity of the fluorine, chlorine, bromine and iodine with alkanes are looking like this. This is the chemical reactivity of the fluorine and chlorine and bromine and iodine finally. Okay, but suppose if you take iodine, if you take the iodine and if it reacts the iodine with methane, then what is the product? Just we will see. This is methane and I am reacting it with iodine. Then what will happen? As already I said, it will produce methyl iodide as well as HI. But the methyl iodide and HI will not produce as it is, because the methyl iodide and HI are combined together and forms the methane and iodine immediately when it is formed. So this type of chemical reactions you have to stop. If you want to get the methyl iodide, you have to stop the production of HI, or otherwise as and when the HI is formed, you have to remove the HI immediately by adding some of the other chemicals. What are the other chemicals we need to add to stop the HI or to remove the HI as and when it is formed? See here, HNO3 is one of the important substance and HiO3 is the other substance. HNO3 and HiO3. This HNO3 when it reacts with HI, it will produce I2 as well as NO2 and H2O. I2 and NO2 and H2O will be produced. 2H2 of course. 2H2 will be produced. In the same way, HiO3 when it reacts with HI, it will produce I2 and H2O. I2 and H2O. That's all. These are the important these two are important chemicals to remove the HI as and when it is formed in the methane iodination. That's all. This is all about halogenation. Actually, this halogenation is a free radical mechanism. It's a free radical mechanism. It's a free radical mechanism. Free radical mechanism can be done in halogenation. That's all. Coming to the next one. Oxidation process. Oxidation process. Already I have given in the previous session, that is oxidation. Oxidation can be done in three ways. It may be done, or oxidation can be done either in combustion form or either in incomplete. Yeah, see here. So combustion, incomplete oxidation and controlled oxidation. Combustion, incomplete oxidation and controlled oxidation. In the combustion process, what will happen? The maximum or excess amount of oxygen you need to take. The excess amount of oxygen you need to take here. In the combustion process, excess amount of oxygen you have to take. But in the incomplete oxidation, see here, in the incomplete oxidation, sorry, just a minute. In the incomplete oxidation, you have to take a less amount of oxygen compared with the sufficient. A less amount of oxygen you need to take. A less amount of oxygen you need to take here. And in controlled oxidation, you have to use the oxygen, or you have to control the oxygen which subjected to catalyst. You have to use, or you have to control the oxidation process. Which subjected to catalyst. That's why this controlled oxidation is also called as catalytic oxidation. It is also called as catalytic oxidation. That's all. So combustion process is there, incomplete oxidation is there, controlled oxidation is also there. These three are very important for us. So let us start one by one. What is the first one? Combustion is the first one. Yes, combustion is the first one. Let us see. Combustion is the first one. Combustion. What is meant by combustion? Suppose if you take any of the alkane like methane, if you heat it with oxygen, then it will produce carbon dioxide and water molecules along with heat energy. This phenomena is called as combustion. So combustion means alkanes. Generally alkanes are very difficult to oxidize. But here this alkane like methane can react with oxygen in the presence of excess amount of air or excess amount of oxygen. Then it will produce carbon dioxide and water. So ఈ రెండిటిని ప్రొడ్యూస్ చేసేటప్పుడు then we can say that this phenomena is called as combustion. In this combustion process it will liberate very high amount of energy. It will liberate very maximum amount of and heat energy will be produced. So there is a small form. See here, this is the balanced equation, of course. So here we can use one formula to calculate or to balance the equation of combustion. I will give the correct formula to you, correct equation to you. CnH2n plus 2 plus 3n plus 1 by 2 of oxygens, when it combines together it will produce NCO2 and N plus 1 H2O will be produced. Of course, along with heat energy also will be produced. Along with heat energy also will be produced. So in the place of N, you can substitute 1, 2, 3, 4 and so on. You will get the combustion equation. You will get the combustion equation. That's all. Okay. Yeah, let us see. I am taking the incomplete oxidation now. In the incomplete oxidation, the methane will react with oxygen in a less quantity. In a less quantity means very insufficient amount of oxygen. If you react it with methane, then it will produce carbon and H2O. The individual elemental carbon will be produced. It is also called as carbon black. It is very danger. Carbon black is very danger. But in sometimes the same methane when it reacts with oxygen, the same methane when it reacts with very less amount of oxygen or insufficient amount of oxygen, then it will produce carbon monoxide with water molecules. So this carbon monoxide is also very danger. So incomplete oxidation is very danger for us. So you have to, if you want to do the oxidation process, you have to give more amount of oxygen to that alkanes. Alkanes ki high amount of oxygen you need to give. Otherwise, the carbon and carbon monoxide will be produced. It is very dangerous for us. And the last one is controlled oxidation. The last one is controlled oxidation. And the last one is controlled oxidation. Okay, let us see the controlled oxidation first. What is meant by controlled oxidation? Controlled oxidation can be done only in the presence of some of the catalyst. That's why it is also called as catalytic oxidation. That's why it is also called as catalytic oxidation. Okay, controlled oxidation. So suppose if you take suppose if you take methane, if you want to oxidize the methane with the oxygen in the presence of copper. Hi Muhammad Shoaib. Muhammad Shoaib, good afternoon. Welcome to Unacademy YouTube channel. Thank you Muhammad Shoaib. Thank you very much. When the methane reacts with oxygen in the presence of copper at about 100 atmospheres, then it will produce methyl alcohol. See here, we are getting the required product like alcohol when the methane is combusted with oxygen, but in the presence of a catalyst. That's why, yeah, EAMCET exam maybe. Hi Srikanth. Hi Srikanth, very good afternoon. EAMCET exam is at about May, I think, because the second year examinations will be conducted in AP at April ending. So the EAMCET examination will be started maybe May or June. Definitely. Okay, it may be either May or the first week of the June. Okay, Muhammad Shoaib. Right. So methyl alcohol will be produced. So this is called hi. In TS also the same thing will be happen, Srikanth. Because almost simultaneously the examinations will be going on. For AP as well as for TS, the intermediate second year examinations will be going on almost simultaneously. So the same thing will be happen to the TS also. Here the methane, when it reacts with oxygen in the presence of copper at 100 atmosphere, it will produce methyl alcohol. Okay. And suppose if I am taking the same methane and oxygen, if I am changing the catalyst, instead of copper, if I am taking the molybdenum trioxide, then what will happen? It will produce formaldehyde. It will produce formaldehyde. It is called formaldehyde. So totally the entire functional group totally gets changed if you change the catalyst. That is the concept which is behind in controlled oxidation. That's why it is also called as catalytic oxidation, because if you change the catalyst, the product is totally gets changed. So methane, when react with oxygen in the presence of copper, produce alcohol. In the presence of molybdenum trioxide, produce formaldehyde. Of course, along with water molecules will separate out. It is a separate case. Coming to the one more important equation, I am taking ethane now. CH3 is called ethane. Again, if I am reacting with oxygen in the presence of CH3CO twice Mn, it is called manganese acetate. It is called as manganese acetate. When you are reacting the ethane in the presence of manganese acetate, then what is the product which is formed? Here CH3COOH is called as acetic acid. So in the previous case, alcohol will be produced. Next, formaldehyde will be produced. Now acetic acid will be produced. Okay, so totally there are changed once you are changing the catalyst. Once you are changing the catalyst, the entire compounds or products are totally gets changed. That's all. So acetic acid will be produced here. Likewise, you can write any of the chemical reactions of controlled oxidation. So there are three different types of oxidations we have. One is combustion, second one is incomplete oxidation, and the third one is controlled oxidation. That's all. Coming to the next one. Isomerization. What is the meaning of isomerization? Very simple concept. It is a conversion of one isomer of an alkane into another isomer of the alkane. So one isomer should convert to another isomer. This phenomenon is called as isomerization. This phenomenon is called isomerization. Yeah, what, Muhammad Soeb? You don't understand this concept? Please tell me, Muhammad Shoaib. Isomerization means conversion of one isomer into another isomer. This is called as isomerization. It is called as isomerization. Conversion of one, yeah, conversion of isomer into another isomer. This is called as isomerization. See here, I am taking one isomer here. CH3, CH2, CH2, CH3. Yeah, Muhammad Shaib, what it is? It is called as dash. Four carbons are there, four single bonds are there. Four carbons means it is but, all are single bonds. That means it is because it is called as N-butane. It is called as N-butane. Once you are reacting this N-butane in the presence of AlCl3 with HCl, AlCl3 with HCl, then N-butane is one isomer. What is the other isomer of N-butane? I think you are very aware about the isomerism. Okay. What is the isomer of N-butane? Muhammad Shoaib, please tell me quickly. N-butane is converted to isobutane. This is called isobutane. CH3, CH, CH3 and CH3. It is called as isobutane. So N-butane is one of the isomers. Isobutane is the other isomer. So one isomer is converted to other isomer in the presence of AlCl3 and HCl is called as isomerization. It is called as isomerization. That's all. Coming to the next example. Suppose if I am taking 1, 2, 3, 4 and 5. CH3, CH2, CH2, CH2 and CH3. It is called as N-pentane. Again, if I am treating it with in the presence of AlCl3 and HCl, the isomer of N-pentane will be produced. What is the isomer of N-pentane? This is the isomer of N-pentane. This is the isomer of N-pentane. This is called isopentane. Or in sometimes it may produce different compounds also. Okay, so these are all the important examples of isomerization. What is the meaning of isomerization? One isomer is converted to other isomer in the presence of AlCl3 and HCl is called as isomerization. That's all. That's all. Coming to the next one, what is the next important chemical reaction? Aromatization. You know what is meant by isomerization? Isomerization means one isomer is converted to other isomer in the presence of AlCl3 and HCl is called as isomerization. Then what about aromatization? Aromatization means conversion of acyclic hydrocarbons into aromatic hydrocarbons. Conversion of acyclic hydrocarbons, that means chain. Conversion of acyclic hydrocarbons means chain like hydrocarbons. These chain like or acyclic hydrocarbons, if they are converted to aromatic hydrocarbons, then such phenomena is called as aromatization. Aromatization. Suppose if you take one example like this, CH3, CH2, 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 CH2 and CH3. Actually it is called as 1, 2, 3, 4, 5, 6. 6 carbons are there, so it is called as N-hexane. N-hexane. It undergoes the aromatization in the presence of 500 to 600 degrees Celsius and 10 to 20 atmospheric pressure, and the oxides of vanadium, chromium as well as molybdenum or manganese of course. Then what will happen? This N-hexane is converts to an aromatic compound like benzene ring. An aromatic compound like benzene. Actually this benzene is an aromatic compound, right? This benzene is an aromatic compound. So we can convert the normal acyclic hydrocarbons into aromatic hydrocarbons which subject to temperature, pressure and catalyst. By using temperature, pressure and catalyst, we can convert the N-hexane to, that means N-hexane means acyclic hydrocarbons, to aromatic hydrocarbons. This phenomena is called as aromatization. That's all. Aromatization is also over. Isomerization, aromatization. Isomerization means one isomer is converted to other isomer in the presence of AlCl3 and HCl. Aromatization means acyclic hydrocarbons are converted to aromatic hydrocarbons in the presence of some amount of temperature like 500 to 600, 10 to 20 atmosphere, and oxides of vanadium, chromium and molybdenum. That's all. This is called aromatization. And finally one important chemical reaction is that is pyrolysis. It is called as pyrolysis. What is meant by pyrolysis? Conversion of or decomposition of higher hydrocarbons into lower hydrocarbons. Conversion of or decomposition of higher hydrocarbons to lower hydrocarbons which subject to temperature is called as pyrolysis. Subject to high temperature is called as pyrolysis. Pyro means temperature, olysis means decomposition of a compound. Pyro means heat or temperature, olysis means decomposition. So the decomposition of higher hydrocarbons into lower hydrocarbons which subject to temperature is called as pyrolysis. So if you do this pyrolysis for alkanes, if you do this pyrolysis for alkanes, then we can say that it is called cracking. Then we can say that it is called cracking. Okay, this cracking is very important for objective point of view. Suppose if you take C6H14, by giving 500 to 600 degrees Celsius, what will happen? It will produce C4H8 plus C2H6. That means it is a higher hydrocarbon. These two are lower hydrocarbons. So the decomposition of higher hydrocarbons into lower hydrocarbons which subject to temperature is called as pyrolysis. And in the same way, the same I have taken C6H14 I have taken at 500 degrees Celsius. If you convert it into C3H6 plus C2H4 and CH4 and CH4. Again, three different types. This is a higher hydrocarbon. These three are lower hydrocarbons. So the decomposition of higher hydrocarbons into lower hydrocarbons with high amount of temperature is called as pyrolysis. That's a pyrolysis. Dodecane I am taking C12H26. It is called as dodecane. It is a higher hydrocarbon. At about 500 degrees Celsius, it will convert to C7H16 plus C5H10. C5H10. So it is a higher hydrocarbon. These are lower hydrocarbons. So the decomposition of higher hydrocarbons into lower hydrocarbons is called as pyrolysis. So up to this, our preparations, properties, physical properties and chemical properties are also over. Tomorrow we will discuss about the multiple choice questions on this alkanes. Until then, keep watching my videos. Thank you. Bye bye.